All right, it's the top of the hour. So I want to welcome you to the first in a series of Blue Waters webinars. I'm Scott Lathrop at the Blue Waters Project here at the National Center for Supercomputing Applications at the University of Illinois. It's a pleasure to have you joining us for this seminar series. We hope that you'll participate in others. At the end of the talk, we'll let you know the next upcoming topics as a reminder. We are very pleased and honored to have Vicia Bird from Purdue University joining us today to talk about Introduction to Data Visualization. I've known Vicia for a number of years, and I always find her talks and her presentations very exciting, and she's doing amazing work at her center with students and with faculty, and so it's a real pleasure to have you join us today, Vicia. With that, I'll turn it over to you, Vicia. Thank you.
Good morning, and thank you so much, Scott, for that introduction. I am excited to be here, to be a part of this, and excited to know that there are so many people interested in data visualization. And so I want to give you an introduction to data visualization. About this webinar, a few assumptions. I'm assuming that you are beginners, for those who are viewing the webinar today. There's no prerequisites required, and so I assume that you are basically interested in data visualization and learning more about what it is and what you can do and how it can help you. There are no software requirements at all for this first webinar. The goals of the webinar are to provide you with an introduction to data visualization. I will give a summary of data visualization capabilities and hopefully help you to identify your first steps towards visualizing different types of data. And we'll talk about what those different types of data might look like. The objectives for the webinar are to explore the underlying principles of data visualization. We will take a look at the data visualization process, because it is a process. It's not just pretty pictures. So we'll talk about what that means. We will explore some visualization applications, and we'll look at different types of tools for different types of data. The expected outcomes by the end of this webinar, I hope that you will understand the purpose of visualization. I hope that you will be able to identify what your data visualization needs are, because everyone's data visualization needs will be slightly different. And so what I want to do is to just give you a gentle introduction to data visualization, help you to identify some tools that you can use that are accessible to you to assist you with visualizing your data, whatever format that data might be in. So for today, I will give you a brief introduction. We will talk about the purpose of visualization. I'll give you a high-level overview, but keep in mind, this is 1 hour, so I'm really not even scratching the surface of this, but again, the goal is to give you a starting point to help you to start thinking about and asking some questions that you may need in order to visualize your data going forward. We will talk about those visualization applications that I mentioned before. And I have in the last section something that I called, you've got data, now what? Or sometimes people say, okay, so what? I've got data, now what do I do with it? And so we are going to address that, and I'm going to give you some starting points as well. We will end with a Q&A session. However, I have built into the webinar some pausing places that we're going to pause, and I will ask if there's any questions going forward. But please feel free to ask your questions. Don't feel like you have to wait until the end of the webinar to ask them. Okay, brief introduction. This is going to be very brief. Just want to give you a little bit about my background to let you know how did I get into data visualization. I've given a number of workshops, and oftentimes people will ask, so if I want to get into data viz, how do I do it? And so my answer to that question is there's no one answer. Everyone that has actually maybe ventured into visualization has taken a different path. And so this is not to say that you have to take the path that I have taken, but it is to encourage you, if you haven't thought about data visualization in the past, you can, and you can do it. It just depends on what you want to do and how you want to do it. So I am at Purdue University, as Scott mentioned in the introduction. I'm an assistant professor in the Computer Graphics and Technology Department, where we are developing curriculum for a new major in data visualization. So Data viz is a very important piece of all aspects of academia, of scholarship, and hopefully I will point some of these things out to you as we go forward. So one of the things that I like to do is to ask, what do you think of when you hear data visualization? And so I'm curious to know, when you heard that there was a webinar on an introduction to data visualization, what are your thoughts? What do you think about that? So normally I would wait, but I'm going to go forward with the presentation to kind of give you some ideas or to point out some things that maybe you've already seen or heard in terms of data visualization. Most of us maybe have seen word clouds that you can see on the slide here in the upper left, where the frequency of a word is depicted by size, maybe color, indicating that the larger the word is, the more frequent it has been or it was in that particular set of text. We've seen or heard of networks, as you can see in the center of the slide. This particular visualization was actually from the class that I'm teaching now. Our students actually took some data and created this particular network. And we've all seen, pie charts and bar charts and geographs, as you can see on the right-hand side. But I also want to show you, here's a nice example that I like to show of a wind map, which is particularly interesting today because our weather is doing some interesting things. But this is real time, and you can see the flow of the wind across the United States. And so this is just an example to show you of some things that can be done, that you can do with data visualization. And here's another one that I thought was interesting, or is interesting, that I like to show, just to kind of show you or give you an idea of, this is what be called an interactive visualization, because as you can see, as I am moving my mouse, something is happening, something is going on. And so this is particularly interesting so that you can see that it can not only be a static visualization, but it can be interactive as well. And so an interactive visualization just kind of takes that visualization up to another level, and it allows people to actually interact with the visualization itself. So these are some examples of data visualizations. So what is data visualization? Data visualization is the process of representing large amounts of data. And we've all seen or we've heard of big data. And so how do we take data and actually generate some information from it without overwhelming? And we'll talk a little bit more about that in the upcoming slides. But in terms of just defining what visualization is, it allows you to understand and process enormous amounts of information quickly. Because of it, it's all represented in a single representation or maybe multiple representations, but it allows you to gain insight from what that data actually represents. So what is the purpose of visualization? It's that one word I just said. The purpose of visualization is insight, not pictures. Oftentimes people will say, well, I just want a pretty picture. What you really want is insight. You want to be able to gain some type of information or some type of a deeper understanding from all of the data that you have. Or maybe you don't have a lot of data, but you want to represent it in such a way so that anyone who looks at your data visualization will be able to understand what that data represents. So the purpose of visualization is insight, not pictures. And in fact, any of my students that I've worked with, they know the answer to this question whenever I ask, what is the purpose of visualization? Insight. So how do we go from taking data to true insight? And what I've done here is I pulled this information from the source that's cited here at the bottom. So I just want to walk through that and just say, as you're going from data to true insight, you're looking at the information that you have, and you're trying to figure out what relationships exist within the data. Then you are detecting, or you want to see if there are any type of patterns that you want to, or you can pick out through the use of data visualization tools and techniques. Oftentimes there are patterns that are present, but because of the size and the volume of the data, we may not be able to detect those patterns or actually see them with the human eye alone. And so that's where data visualization, or the tools that you can use, will actually come into play. And it helps you to gain more knowledge as to what that data represents. sorry. Once you have that knowledge or the how you want to, it allows you, enables you to have an understanding of what type of data that you're dealing with, or how can you synthesize new knowledge from what you already know. And then ultimately what we want is, like I said, that insight. And that insight allows you to build on not only the knowledge that you just gained through this process of data visualization, but it takes into account those things, that knowledge that you already know. And so just pulling those things together helps you to be able to have a better and a deeper understanding of the data that you're working with. And so it's all about insight. So the purpose of visualization is insight. So are there any questions so far? And I know this is the first break that I put in, but I just want to make sure that you understand that visualization is a process, and you will hear this throughout the webinar. And so what we're going to look at next is, what does insight lead to? So we've talked about the purpose of visualization is insight. What exactly does that lead to, or what does that enable us to do? So it looks like we have a question. The question is, what can be some good alternatives to Venn diagrams? Sometimes we want to look at the intersections, unions of data sets, but Venn diagrams aren't informative. So thank you so much for that question. I am going to defer the answer to that until we get further into the webinar, because I have an actual slide that I think will be able to address that. So if you will bear with me, I do have a slide, but it is towards the end of the webinar. But thank you so much. That is a very good question. So insight leads to discovery, visualizing patterns over time, specifically spotting differences. And so this is a very simple example that I've provided here. And so the idea is to be able to pick out those differences between those two pictures there. And so if you weren't able to identify them, on the next slide you can see I've identified them. And this is a very simple, it is black and white, but just imagine if you have lots of numbers, a huge amount of numbers, that you are expected to detect some type of pattern that exists within that data. And so having some data visualization tools or techniques in your toolkit or toolbox that would enable you to actually pick out those patterns in a more efficient manner, that can be very beneficial. And it helps in terms of time, because it takes a lot of time to actually go through the data visualization process, sometimes depending on what the data is. So insight leads to discovery. It allows us to pick out different patterns, to spot differences. It helps us to make decisions. And so this particular slide is representing or referring to the Human Genome Project. So there is so much information that was collected that is hard for researchers to actually discern or figure out, what parts of this can we use right now. In fact, there are some parts of it that we don't even know the answers to these questions, but that information is there. And so what data visualization tools and techniques will enable us to do is to ask those hard questions, or to ask those questions that we don't even know we want to ask yet, but having the tools to facilitate the ability to get that information out of it that we're looking for is very, very helpful. And so having data visualization tools, insight, helps us to make decisions based on the information that we're able to get out of it. Analysis of data. And so one of the things that data visualization allows us to do is to analyze data, to see what we have, to actually draw out or to take a deeper look at what's there. Sometimes you may be thinking, or you expect one answer, and with data visualization, you find or you discover maybe there's another answer or some other piece of this that I was not aware of. And so the analysis of data is one of the things that insight leads to. Insight allows us to explain things, or to look at spatial relationships. And so this is a very good example that I like to use, just to show you the growth of two well-known stores over a period of time. And so what I'm going to do is just kind of talk through this as this goes. But what you can see here from flowing data, this is data from both Walmart and Target. And as you can see, the growth of these two particular chains over a period of time. And as you can see, they started out roughly around the same time. But as they continue to grow throughout the years, you can see that one actually had more and more growth than the other. Not to say that one has outdone the other, but this is an example of what you can do or what can be done with data visualization. And you can see that things are popping up in both of these windows over a period of time. You can see the store count for both of them. And so it's kind of interesting to see how these store chains kind of spread out across the US. And so now these numbers or these representations are for the openings of stores. This does not include those stores that may or may not have closed. But the whole idea here is to show you how you can use data visualization to convey information. And so I'm hoping that by seeing this, it has a stronger impact rather than me just saying, okay, one store grew at this rate and the other one grew at another rate. Hopefully by seeing this, having a visual representation of this, you can actually see that for yourselves. And so that's another example of how insight leads to explanation, and through data visualization, we're able to see this or see it represented in a visual way. The other thing that data visualization leads to is storytelling. And so this is the next step for data visualization. Now, it is fantastic to have a visualization that you can gain more information from, but allowing the users to actually interact with that data and actually telling the story that you want to tell. This is a crucial part of data visualization. And so what I've done in this slide is I've taken a snapshot of a cover feature that was in Computer Magazine 2013, but it's very relevant. And so I do encourage you to take a look at this. But again, storytelling is a key feature, a key part of data visualization. And no introduction to data visualization, in my mind, would be complete without having a reference to this very well-known visualization. And so what I'll do is I'll take a moment to actually trace through it and just kind of point out some key features here. If you have not seen this visualization, I think it is very interesting. It will be very interesting to you. If you have seen it, I think it still would be very interesting. So let's talk about what this is. So this is the storytelling with visualization, and it is a depiction of Napoleon's invasion of Russia. And if you Google this, you will see this in many different visualizations as well. So what do we have here? We have a map that's showing you, a visualization that's showing you the invasion, which started with an army size of 422,000 troops. The thickness of the line indicates the size of the army as they move from left to right. And so as you can see, as they're moving from the source to their destination, they arrive there with a significant lower number of what they started out with. And so I'm paraphrasing, and just in the interest of moving forward, there was a retreat. So they decided to go back the path, or along the path that they started. And so in this case, the dark line indicates the path of retreat, and also still the thickness of that line indicates the number or the size of the troops in that army at that time. And so as you can see, some other factors came into play, like weather, and you can see as it got colder, the thickness of the line gets smaller and smaller until ultimately they're back at their starting point with an army size of 10,000. And so just seeing this in a visual form like this, hopefully, again, has a stronger impact than for someone to just cite numbers and facts for you. And so one of the reasons why this is such a valuable data visualization is because you're seeing so much information in one visualization. You're seeing a map of their invasion, the path that they took, maybe and some detours maybe that were taken. You're seeing a map of their retreat. You're seeing a map that's indicating their temperature So there's a lot of information contained in this one data visualization. And so this is an example of what you can do. Now, I'm pretty sure your data may look totally different from this, but the whole purpose of this is to give you some idea of the different types of things that you can show in one data visualization. In this visualization, there is a lot going on, but it's represented well, and it is portrayed in such a way that you can understand what the author was trying to portray here. So insight, the purpose of data visualization is insight. We talked about, or I shared with you how it helps us to analyze data. It helps us to explain things, to tell a story. It helps significantly in decision making and in the discovery process. So there's a lot of things that can be done and that you can do with data visualization. So are there any questions at this point? This is a nice stopping point to see if there are any questions. If not, then we will proceed to some of these data visualization questions. Okay, so we will proceed. Again, please feel free to ask these questions if you have them. So we've talked about data visualization. The purpose of it is insight. We've talked about what does insight lead to. So why is data visualization important? So let's take a look at some of the different types of visualization applications. So what you will find is that your data will dictate the type of tools that you will use. In this case, in this particular slide, I'm showing if you have biological data. So this is the visualization of biological data. This is typically grouped together with computer animation, because if you've seen any of the visualizations that are created, you will see some of the same techniques are used for visualizing scientific or computer animation. So a lot of the tools and techniques and methods that are used in the computer animation field are also used to visualize biological type data. And so any of the areas or the applications that I'm going to show you or share with you in this presentation, there is probably a conference or a workshop or something of that nature specifically for that particular type of data visualization. So if you're interested in any of these, I do encourage you to just take a look. You can Google BioViz or any of the other visualization applications that are shown in this presentation as well to find out more information. So if you have biological type data, that usually falls under the category of BioViz. And so now when I say under the category, these are categories that I am, the way that I am categorizing these areas. Some people may choose to do it differently, but for me, in terms of depending on the type of data that you have, if it's biological data, then I would say BioViz. What if your data is not biological data? What if it's survey data or social media data? Typically that falls under information visualization or InfoViz. And again, there's a conference or workshop, many workshops. In fact, this week covers all of these types of different visualization applications. But this is the area where it's kind of like a catch-all. You know, if it's not geotype data, or if it isn't simulated data, or if you're not sure where it fits, most likely it probably fits under information visualization, because there are a lot of different types of tools that can be used to help you to visualize the data that you might have that falls under this. So social media type data, observed data, maybe survey data, any type of non-numerical information typically falls under the heading of InfoViz. What if your data is geographic data? You know, you may want to indicate some type of geographic locations. That falls under the heading of GeoViz, or geographic visualization. And there is a whole host of different types of tools that are used for this area as well. And so what it does is it helps you to communicate geospatial type information. So if you have longitude and latitude type data, there are tools out there that you can use to actually visualize that data. And it allows for exploration and, again, decision making. All of these tools, all of these areas, visualization helps in actually making some decisions as to how you want to visualize that data. Or maybe you're looking at doing some comparisons. The options are unlimited. It just depends on, you're limited by your own imagination and your will to actually go work through this process to get the output that you're looking for or hope to get. If you were to Google visualization, most likely scientific visualization will be at the top of that list because that has been the area that has been most prevalent in the past. As I mentioned before, with the biological data, a lot of the tools and the techniques that are used in scientific visualization are actually used in the gaming industry. If you look at the realistic renderings, for those of you who play games or have played games, I'm sure if you don't, you've seen them. Those realistic renderings of volumes and surfaces and illumination, all of those tools and techniques are actually used in scientific visualization as well. So you've probably seen these applications, but maybe have not given them much thought in this context. But as you can see, hopefully, these are the areas in which data visualization across the board have been and continue to be useful. So those are some applications of data visualization. We looked at InfoViz, BioViz, scientific visualization. There are others. Like I said, your data will typically dictate the type of tool that you will use in visualizing your data. So what we're going to do now is talk about, give you a high-level overview of this process, because I mentioned before that data visualization is a process. So what does that process look like? This is a very good example that I think from the book Exploring Visualizing Data, Exploring and Explaining Data with the Processing Environment by Ben Fry. And so this gives you an outline or show you this data visualization process. So we're showing typically 7 steps. But what I want you to keep in mind that these are starting points. So these are stages that in the process of visualizing your data that you will go through, and whether that is for InfoViz or BioViz or scientific visualization, the process might look slightly different or maybe call something slightly different. But if you were to map these things back, you will see that these basic steps are actually incorporated into those different processes. And we'll take a look at a couple of them in the upcoming slides. So what's the first step? Acquire. You need to have some data. So you have data. What do you need to ask yourself some questions? And what does that data look like? What are the storage requirements for that data? Because that's going to help you going forward. Am I going to have to provide some structure for this data? And that is the next stage, which is parsing, is where you take this raw, sometimes complex data. Oftentimes the data that you get will not be nice and neat and clean, and oftentimes it's dirty, which means that there's no structure to it at all. And so you will have to take some time to actually parse that data to provide some structure to it. Once you have the structure, you want to remove all of it, all but the data of interest. So if you think about, for example, social media data, if you were to pull down all of the social media data, but you only expected, or you're only looking for one particular relationship that you're looking for, or one particular variable, that's a lot of data. And so what you would want to do is to think about what is it you're interested in, remove or extract, filter what those pieces that you want, and that will give you a smaller data set to work with, and hopefully you'll be able to manipulate that or to move it through this process a little easier. So once you've removed all but the data of interest, you will want to mine that data, and that means you will apply some type of methods, maybe from statistics. You want to try to pick out those patterns that we talked about before, maybe apply some type of mathematical context to the data that you have. And then ultimately you would want to choose some type of basic model, such as a bar graph or a list or tree. Depending upon what you hope to convey, you would want to do a first representation of that data. Which brings me to a point that I want to share, is that when you're doing data visualizations, you need to give it time to actually go through this process, because your first visualization will not be your last visualization. And so oftentimes we think that data visualization, this is the last thing that I'm going to do. I've got all my data and I just want to create a quick visualization. It is a process, and it is an iterative process. So I see I have a question here. It says, what BioViz applications would you recommend? Can you recommend applications that are used for BioViz and scientific visualization, especially free apps or online apps and Mac-friendly apps? That is a very good question. So for scientific viz, the tools that I typically use in any of the workshops and any of the classes are open source, which means they're free because I don't want them to be an hindrance of purchasing the software. So two tools that I typically start with are ParaView and Visit. And so in a couple of weeks, I will be giving a second seminar, a webinar on an introduction to scientific visualization featuring ParaView. And I believe there is another webinar that's coming up, an introduction to scientific visualization using Visit. And so both of these tools are open source and they are free. And we do have additional webinars that are coming up to provide you with a more introduction to those. So stay tuned and look for those. And I think Scott will talk a little bit more about the upcoming webinars after this one as well. So thank you very much. And they are multi-platform. So they should run or will run on Windows, Linux, Mac. And so that's one of the key features about these two applications, in addition to being open source. So if you are inclined to contribute to the open source part of that, you can do that as well, or you can write your own code to address whatever features that you would like to address or to explore your own data. So thank you for that question, and stay tuned. We'll have some more information about different types of tools that are available and the different webinars as well. So let's say you represented your data, you've done what I like to call a quick and dirty view of the data just to see what you have and what you're working with. One of the beauties of data visualization is not only helping people to visualize what they expect, but also helping them to see something in the data that they did not expect. And that is the true light bulb moment, or the moment where you can see or you feel that you really helped this person, because we all come into it thinking, I know what this looks like, or I have an idea. Sometimes I have an idea of what this looks like, but to be able to use data visualization to help you to not only see what you expect, but to see the unexpected as well, that is the icing on the cake to me. So you've used some type of basic data visualization procedure or method to create like a bar graph or a tree or a list. The next step is to refine this. So like I said, your first visualization will not be your last. I can almost guarantee that, unless, of course, what you get out of it, you say it's good for now. But there's always the step of, how can I improve this, or what can I do to improve this? How can I go forward with this? And so this refine step is very crucial, because it allows you to tinker or to refine it, to improve upon the visualization that you created. And then lastly, to add some method of interacting with the data. So one of the things I hope that you can see in this is that I did say that it is an iterative process. You see these little arrows that go from one stage or process step to the next. So you could be in any of these stages at any time. Sometimes it's presented in this particular slide as in a linear fashion, but you may or may not end up in all of these, or you may end up in some. But the idea is, if you don't know where to begin or what your next steps are, or maybe you'll get to a point where you're using a tool and it's not doing, or it's not giving you the functionality that you would need. Just knowing where you are in this process will help you to understand, okay, what should my next step be? So you are going to see these particular stages in any of the processes for information visualization or scientific viz, or BioViz. They may look a little different or maybe called something different, but if you actually look at the underlying principles, you will see that each one of these represented steps are actually represented in those processes as well. So it's just something that's good to know. So the process of visualizing data is about taking that raw data and converting it to a form in which it is viewable and understandable by humans. And so unless you've seen this slide before, there's no way for you to know what this data set on your left actually represents. And in fact, this is a subset of data that could possibly represent almost anything, because I haven't given you enough information to let you know what that represents. But there's no way for you to know that that data could be representing the image that you see, or the space shuttle and the rocket booster visualization on your right. So this little arrow in between, that's where the visualization process happens. It's taking that raw data and actually representing it using some tools and methods that will allow you to have a better understanding of what that data visualization represents. And coincidentally, that figure on your right was actually generated using ParaView, as you can see in the cited source at the bottom of the slide. So ParaView is going to be one of the tools that we will take a look at in an upcoming webinar. So why do we care? You know, some people say, you know, yeah, this is nice. I don't care. I just want a really cool picture. I just want something that looks good. You should care, because visualization is the tool that will take us forward from the traditional output of high performance computing. And so with ParaView and Visit, you have some opportunities to do some high performance computing visualization. So what do I mean by that? That means sometimes your data is so big that you need these high performance resources. Maybe you've been trying to run your data or create visualizations on your laptop, and you're exceeding the capacity of it in terms of RAM, maybe in terms of space. Maybe you have a data set that is so large that you need a cluster or you need access to those types of resources that will allow you to run things in parallel. And so Visit and ParaView are two applications that are set up for that. They will allow you to run your visualizations in a parallel environment, and so, or distributed environment. Okay, we have another question. Any suggestions for tools and readings about InfoViz? So when you say tools, I'm assuming the different types of tools that are available for information visualization. It depends on what type of data you have and what you want to do, what you want to convey. So if you have network type data, maybe you're looking at, and network could mean any number of things. I'm going to assume at this point, let's say if you want to look at social media data, that's definitely network type data. An application that is also free is Gephi. That's Gephi, Gephi. That's online, it's available. It will allow you to visualize hundreds and thousands of different types of different nodes in your data. Tableau is another application that is also free. Tableau offers different versions of Tableau. So you have Tableau Desktop, you have Tableau Server, and I think there's maybe a few more of those. There's Tableau that you can publish on the web. So you have to be careful with that as well. So if you're working with data that is not, you're not ready for public consumption, or maybe you're working with it to go into publication, so you don't want to use Tableau, the web version. You want to use the Tableau Desktop because that would allow you to control the sharing of that data. The web version, when you publish it, it is published, and so that means it's on the web. So just be careful about that. In terms of readings, oh, there is a lot. So what I will do is I will provide maybe a list of references, or just to get you started on the Slack channel that we will have. I will be monitoring that, or taking a look at it a few days, maybe a week after for a week after this webinar, just to answer your questions. And the reason why that's not a short answer that I can give in terms of a reading list, but I will be more than happy to post that information or make it available to you and to the group, those who are watching via the Slack channel. So thank you. That's a very good question. And those are only 2 tools. So keep in mind, there are a lot of tools. And in fact, I do have a slide at the end of the presentation here that we're going to explore, and it will give you a lot of different types of tools, way more than I can cover in this particular, within the time frame that we have. So we have another to any suggestions for BioViz tools. Well, again, there are a lot of tools that are out there. I'm going to say or recommend, if you are not familiar with the Ski Institute, which is at the University of Utah, they develop a lot of visualization tools, particularly for scientific viz, a lot of tools that will allow you to look at biological type data. And again, we have to think about, the question becomes, what type of data are you talking about? Are you talking about X-ray images or CT, or are you looking at different types of biological data? So the conversation will have to be had in terms of specifically what does your data look like. But in terms of looking at scientific visualization type images, then I think the Ski Institute offers a wealth of different types of applications that they develop themselves, and also peer review and visit are also some things, some applications that may be helpful in taking a first look at your data. We have another question. How much programming does one need to know before starting on these tools? And what would be the first type of language would you suggest? R. So it depends on your level of interest and commitment and time as to what you're doing. So all of these tools, the open source tools, they are open source, which means that you can see the coding that is involved. And if you think about the area or the concept of open source, it depends on if you have a tool that is doing almost everything you need it to do, but perhaps you have come up with some different type of data that's in a different format than what the tool is expecting. That's where those programming skills will come into play, where you can actually, instead of reinventing the wheel, you can write code to supplement the code that already exists. And so you'll be building on something that does most of it for you, but then you can add in through the programming skills that you have, or maybe get someone to help to actually expand that tool so that you can, for example, with peer review and visit, you can write your own reader, which means that if you have data that is not in the format that these applications actually recognize, and they recognize hundreds of different types of data formats, and it's another positive thing about these applications is that they recognize an enormous amount of different file formats. But you may be working with some data where you created your own file format for your data. You can, if you're comfortable writing code, you can write your own code, and they have very good documentation in terms of helping you to do that. And typically, if you are new to any of these applications, the knowledge base, the user list, they are very good about getting back to you or responding to your questions. And chances are, if you're new to any of these, someone has already asked the question that you are asking. And so just think about taking a look at their database of knowledge, because and some people will point you and say, okay, this question has been answered before, take a look at this. So it's not like you're out there on your own, but there's a lot of information out there for new users if you're new to the process. So what type of languages would you suggest? If you are new to data visualization, and I mean totally new, you haven't done any visualizations before, and maybe you haven't done any programming before, then I would suggest starting with processing. So that is a visualization programming language that gives you, again, a very gentle introduction to actually visualizing your data. You can do a lot of different things with it. R has a very steep learning curve for some people. And so if you're already familiar with R, it does have some visualization capabilities. And so I would encourage you to explore that. But if you're brand new to data visualization and you are just wanting to get your feet wet and you want to see, what you can do, I would suggest starting with R. One language that you could learn that would be helpful in writing some of the programming parts or contributing to the open source is Python. So Paraview and Visit have a Python shell, and you can write code that will allow you to call those libraries that are already built for you. And so that's another way that you can get the feel of the visualization tool. And also there are tutorials that will help you to just kind of go through and see what you can do. So those are just a few suggestions. So it really depends on how much programming is, how deep you want to get into that process. If you're happy with the tools that you're using and they are feeling that functionality for you, or if it gets to the point where it's doing almost everything you needed to do, but there's just one last thing that you need to get done to help move your data forward or your research forward, then you may want to consider doing some visualization programming. And again, these are some options. There are others that you could consider, but if you're new to the field, I would say start with processing and then graduate on. Definitely Python would be good if you're planning to or would think you might want to write some code to help with the interfacing with Paraview or Visit with your own data. So on this slide, we're going to take a look at the scientific visualization pipeline. And so what's missing from this this pipeline that I'm showing is this one thing, as I mentioned before, your first visualization will not be your last visualization. And so it's that feedback loop. And so if you take a look at the reason why I like this particular slide is because it's showing you what's actually happening to the data as you move through this process. And so even though the labels or the boxes, rectangles on your right may not have the same names that the previous slide had for those 7 steps, if you think about it, it's basically all of those steps are included in this process. So if you look at what happens to the data, you have to have some data. That is the meat of this entire process. If you don't have any data, there's nothing to visualize. So you get that data, whatever that data might look like. You have to prepare it, and you do that by applying or analyzing some filter or applying some filters. And in fact, with Paraview and Visit, 3 steps: read, filter, render. Those are the key things, high-level things that you'll be doing and that we will cover in upcoming webinars. But it is this process that will be going on behind the scenes. And so what this is showing you is literally what happens to the data as you are working it through or are walking it through this process. So when you use these data visualization tools, they will all have or should have some similar type of techniques that are used across the board. So you should be able to pick up any tool and look for these different techniques that will be used. And I think I have a slide coming up to talk about that. But just keep that in mind, that as you are using these visualization tools where they're doing the things for you, this is what's happening behind the scenes. Most of the times, depending on your level of interest and how deep you want to go into this, you may not even need to know what's going on behind the scenes, but it's always good to know in the event that you do need to take matters into your own hands in terms of writing some code. You'll know where you are in that process. So, as I mentioned before, data is what dictates the type of tool that you will have. And data can be in almost any shape or form. We see data all the time on a daily basis. And so what I want to do is just walk through this scientific pipeline so that you can see what happens. So the first step is your input data. And again, that data could be almost anything. It could be simulated data. It could be images. It could be some measured value, or it could be social media data, as I mentioned before, any type of data. But in this context, we're looking at scientific visualization. So that first step is to get the data. The second step is to filter or to analyze or to reformat it. Take a look at it and see, what do I need to do to prepare this data? How do I deal with noise? Most likely you'll want to filter that out somehow. How do you deal with missing numbers or missing values? That has to be represented in some way. And you should document what you're doing. So the whole process is documentation, figuring out what you're doing, but not only figuring it out, but documenting what you're doing for reproducibility, because you want to be able to actually come back and do these things again, if not with this data, with some other data as well. So the second step is to analyze or filter format. You want to clean up the data. And so just that, so that you know, the acquisition and the cleaning phase of data sometimes takes some time. So if you don't get frustrated and think I'm not making progress or it's not moving fast enough, that's one of the reasons why I say you should allow time to do the data visualization process. It's not just about creating a picture. You want to understand what you're actually working with and how you can best represent that data. The next step is to apply some scientific visualization techniques. And so in this slide, these are some common types of techniques that you'll see in any other applications in which you're able to look at maybe scientific type data or biological data, contours, create some contours. Maybe you want to clip the data. You only want to look at a certain part of it. Maybe you want to do some thresholding, only show data points up within a range of values. And so all these are different types of techniques that are applied. These are the different types of techniques that we will look at specifically in the peer review webinar. We will have a small data set that you can work with, and you can apply these different types of techniques so that you can see what the output of these techniques looks like depending on the data. So typically, again, this is from scientific data that you will apply these different types of techniques. But I also want to say that there is nothing preventing you from taking a tool that is maybe designed for scientific type data and applying it to information visualization type data. You know, these are just starting points. These are places that we know the data has been represented using this tool effectively, and it has been helpful in the past, but that's not to say because it is peer review, you cannot, and it's specifically designed for scientific viz, that you can apply it to some other type of data. If you can get your data in a format that these applications will recognize, then you can definitely see what you can do with that. So don't feel like you are restricted just because your data looks like this. You can only use this type of tool. Just be aware that it may take a little bit more motivation, a little bit more maybe programming to get it there, but that's not to say that you can't use those tools. So the fourth step, or the next step, is to map to some type of geometry. And I'm going to speed up here because I think I'm running out of time. But you want to give it some shape. You know, is it a 1D or is it 2D? Is it 3D? And the answers to those questions will determine what type of geometry will be applied to the data. And the reason why we want to have some geometry is just so that we can render it in some way, so we can see it in a visual form. And again, it is an iterative process. And so in that iteration, you are refining it as you go forward. So that first visualization that you present or you generate will not be your last. And here are some examples of some different types of visualizations that are possible. These are scientific visualizations created with either peer review, or you can also do these with visit. And so this is just to show you, to give you some ideas of what different types of data visualizations can be created using peer review and visit. So this looks very complicated, and in some cases it is, but they also do simple visualizations as well. So I don't want to scare you to think, well, I have to have this huge data set and it has to look this way. Peer review and visit can accommodate the simple graphics as well as the more complicated ones as well. So be open to that. So what is the importance of data visualization? Data, regardless of what your major is, regardless of what your research area is, even if you're not in research, in industry, data is everywhere. If you haven't heard the term big data, it is an opportunity for us to utilize visualizations to gather and to ascertain what can we do with this. So the volume of data, these are some challenges when you look at the 4 V's of big data, and sometimes there are 5, but I just wanted to list or to show you there's different types of data that are out there. And how do we get information that's related, but from these different types of data, but related to one record or to one, for example, if you go to the doctor, different types of data is collected from different physicians, but you have one patient. And so that's an example of the variety of different types of data. And that's just one scale, but you can think about, I'm sure, other types of opportunities where variety is a problem or is a challenge. And there's the uncertainty of data. So due to time, I'm not going to talk a lot about that, but in this slide, you can see, and I do encourage you to take a look at this in more detail at the link that I've provided below, but it just shows you some of the challenges that are out there in terms of the enormous amounts of data that we have, the velocity of the data, how fast we're able to stream data to your cars. You have sensors in the cars, so they are collecting data. You have wearable devices, that's collecting data. You go shopping, they are collecting data. So this data is everywhere. And so being able to actually do something with that data is very important. So you should care about it because there is a demand for people who understand the visualization process. There's a demand for people who can take large amounts of data and actually draw from it some type of visual representation that does not overwhelm. So data is not going anywhere, regardless of, like I said before, your major, your research interest. At some point in your life or in your career, you will visualize something. So that could be large scale or small scale, but you will visualize something. So why should you care? Again, everywhere you look, there are opportunities to incorporate data visualization into your research, into the different areas, whether it's STEM or non-STEM. Just daily usage or daily interaction allows you to have an opportunity to actually look at how can you transform this information in such a way that it makes much more sense to a broader range of people other than just the researchers who are actually working with that data. So you've got data. Now what? What does your data look like? So these are some questions that you should ask. What does it look like? What needs to be communicated? What are you interested in utilizing? Are you looking to analyze the data? Are you looking to explain something? So data visualization can be used for communication, for fact finding or knowledge finding, knowledge building, to making discoveries. Take a look and see what's been done before, because that's going to help you in figuring out what you want to do differently going forward. Or maybe you want to build on what's already been done before. The question, where do I start? So there are different areas, different types of data. Someone asked the question earlier on, where do I start in terms of, I think he said Venn diagrams. This is an example of, I think it's very useful. Let's see, can I reposition this? Oh, hold on. This is an example of what would you like to show. And so if you know what your data look like, and you know that you want to maybe show some relationships that exist within the data, or if you want to show some distribution that exists within the data, maybe some comparison or composition, I think this is a very good starting point to kind of give you some ideas as to the different way that you can represent your data. And so again, any of the information that I provided today is just that. It's a starting point for you, but just be aware that there are many, many opportunities and many possibilities to represent data in more than just one form. So I am going to quickly here. So again, visualization is a process. Here are some visualization tools. Again, this does not scratch the surface. For information visualization, Gephi, I mentioned before, it's a good starting place. Tableau, it is not open source, but it is free. So if you Google it, any of these, you'll be able to access this. For scientific visualization, ParaView and Visit, there will be 2 more upcoming webinars dedicated specifically to each one of these. If your data looks more like geographic type data, I've listed 2 applications here, 2 things that you can explore, ArcGIS and D3. So now D3 you can do a lot of things with it. I listed it under geo visualization, but you can actually do some visualizations outside of GeoViz with D3. So do take an opportunity to take a look at that. And if you're interested in cybersecurity visualization, as you can see, due to time, I would not have enough time to actually go through and actually talk about the different types of visualizations that are capable with cybersecurity visualization. But I've listed these two search terms that you can go through Google and look for a survey of visualization for cybersecurity or security visualization. And that will, again, give you a starting point for where to look for those different types of tools. This is a link if you want more. Sometimes it can be a bit overwhelming if you're not familiar with or you're new to the data visualization. But if you're looking for different types of tools, someone asked about BioViz tools. If you go to this site, it has over 430 data visualization tools and books. So be aware that it can be a bit overwhelming. But if you hover over any of the links there, it will show you or give you some suggestions as to what you might want to take a look at. And let's see if I can do this. Maybe not. But if you just hover over any of those things, it will highlight if you're looking for data types, if your data is multivariate data, where you can look if you're looking for a statistical tool that will allow you to do data visualization. If you're looking for spreadsheets, I mean, this is it's a resource. It's a lot of information, but I think it will be very helpful for you, again, as a starting point. And so with that, I believe I've reached my time. So thank you so much. If you have any more questions, feel free to send them my way.
Thank you very much, Vitria. That was a wonderful presentation, and we're pleased to have you lead off this series with such a wonderful presentation. To those still watching, we will let you know as soon as the video of this is recorded and posted, so you can play it back or look at segments of the video.
And Scott, someone just posted a question wanting to know if the slides will be available after the presentation.
And you're making them available?
Yes, they will be.
Okay, so for those listening that asked about the slides, we'll post them on the website, and we'll send you an email to let you know once they're posted if you've registered for this webinar. And do we have our final slide? So just a reminder of some upcoming talks that we have. Next week's talk, do we have the slide up?
Should I stop sharing?
Oh, yeah.
Okay.
Stop sharing, we'll get the local. All right.
Okay.
So next week's presentation on Wednesday, March 8th, will be by Scott Callahan from the Southern California Earthquake Center, talking about an overview of scientific workflows. And as Vitria mentioned, there are a number of visualization talks coming up. March 15th will be a talk on visit. And then Vitria's talk on peer review will be 2 weeks after that, correct, Vitria?
Mm-hmm. Yes, that is correct.
Okay, and we'll send you a short 3-question survey yet today to get your quick feedback on the value of this presentation. With that, then, we thank you all for joining us. We look forward to seeing you on the future seminar series. And Vitria, thank you again.
Thank you. Bye-bye.
Goodbye, everybody.